Para sa course na Geotechnical Engineering, solve natin tong problem na to. So the confined aquifer shown below. The aquifer has a hydraulic conductivity of 40 meters per day and a porosity of 0.25. The piezometric heads in two observation wells, 1,350 meters apart, are 65 meters and 60 meters from the common datum. The aquifer has an average width of 4 kilometers. Determine the following. Una yung rate of flow of water, in which cubic meters per day, tapos yung seepage velocity, so meters per day. So pwedeng gamitin natin dito yung concept sa constant head. So constant head dahil yung difference in elevation nila nung mga piezometric head, so constant. No? So K is equal to VL over AHT, in which yung K ay yung hydraulic conductivity or coefficient ng permeability. Tapos yung V is yung volume ng water collected dun sa constant head na test. No? So L ay yung length ng specimen, A yung cross-sectional area ng specimen. So dito yung length ng specimen or length ng flow ng water through the soil. Tapos yung A yung cross-sectional area ng specimen. So dito, cross-sectional area ng aquifer. Tapos yung H yung head loss. So difference ng heads or ng pressure heads or elevation head. So tapos yung T ay yung duration ng water collection dun sa constant head na pagtetest no, sa flow para makuha yung hydraulic conductivity. So ganito yung setup nun. No? So, meron kang soil sample na may length. So, yun yung flow ng or kung gaano kalayo yung idadaan ng fluid dito ng water. Tapos, yung ang ginagawa, so, kailangan masustain yung constant yung level or yung value ng H. Tapos, mag-flow yung water dun sa through the soil. Tapos, dun sa outlet, dun kukunin kung gaano karami yung volume ng water na na-collect at a given time. So, para makuha yung hydraulic conductivity. So, pwede rin naman pag nakukuha mo na yung hydraulic conductivity, at a given time, makakuha mo kung gaano karami yung volume ng water na makakollect mo. And so, pwede natin i-derive yung equation na to. So, Q, yun yung discharge or flow rate, equal sa area times yung velocity. So, area ng soil tapos yung velocity ng flow. So, equal sa, pwede rin sabihin na volume per unit time. Tapos, yung velocity equal sa K times I. So, yung K yun yung hydraulic conductivity tapos yung I yung hydraulic gradient. So, hydraulic gradient equal yun sa so difference in the heads or yung head loss over yung length ng flow ng water through the soil. So, substitute na lang dun sa equation. So, K multiply sa yung I na H over L equal sa volume over time. So, yun nga. So, volume equal sa AKH times T over L. Or ito yung derived equation. Tapos, pwede rin na yung V over T equal sa Q. Kapag yung hahanapin is yung rate ng flow ng water. So, ito yung pwedeng gamitin equations. So, ito yung mga nasa given. So, K is equal to 40 meters per day and yung porosity ng 0.25. Length ng flow or length ng aquifer na i-consider. So, 1,350. Tapos, yung head loss. So, 65 minus 60. Tapos, yung area ng aquifer. So, sabi dyan na 4 kilometers yung width. So, yung depth niya is 25 meters. So, yun yung area. So, para makuha yung rate of flow, so, gamitin natin yung equation na ito. Yung hydraulic conductivity equals sa Q times L over A times H. So, divide na lang both sides ng L tsaka multiply ng A times H. So, flow rate, substitute yung mga nasa given. So, therefore, 40 meters per day times 25 times 4,000. So, 4 kilometers. 65 minus 60 over yung length na 1,350. Therefore, flow rate ay 14,814. Tapos repeating 814 cubic meters per day. And so, para naman sa seepage velocity, ito yung derived equation. So, seepage velocity denoted ng V sub S equals sa velocity over yung porosity. And so, pwede natin i-derive to gamit tong concept na to. So yung flow rate Q, equal yan sa area times velocity nga. So, equal din yun kasi sabi, no? So, saan ba mag-flow yung fluid? Doon lang naman sa void. So, yung kino-consider pala na A times V yung area times velocity, yun yung average dun sa total area. Tapos yung exact flow or para dun sa exact na speed dun sa, yun nga yung seepage velocity. So, area ng voids multiply sa volume ng area ng voids multiply sa seepage velocity. So, equal lang sila. So, total area equal sa area ng voids plus area ng soil solids. And so, pwede nating i-substitute dun sa equation. So, therefore, seepage velocity. Tapos, multiply na lang ng L para makonsider natin as volume. So, volume ng voids plus volume ng solid particles over volume ng voids. Ayan, dun sa concept ng i-consider natin yung per unit ng volume ng solid particles. So, equal yun sa 1. Tapos yung volume ng voids dahil E is equal to volume ng voids over volume ng solid particles. So, E na lang yon. Tapos yung N ay volume ng voids over total volume. Kaya E over 1 plus E. Kaya yung seepage velocity equal sa velocity over porosity. So, dun galing yung equation na yan. So, pwede natin itong isolve. So, seepage velocity equal sa velocity in which yun yung Q or Q over A. So, substitute natin yung na-compute tsaka yung mga nasa given. So, yung nakastore sa A over, so yung area 25 times 4,000 times 0.25. So, therefore, seepage velocity ay 0.592 from 592 pa na to meters per day.